Okay, let's talk about magnetic flux density and AC generators. Okay, so if you remember that magnetic flux is how the magnetic field lines is coming out of a surface. Now, magnetic flux density is you dividing it per area. So if you think about it, it's how many field lines, per area. If you think about it that way, okay. So how many field lines? So how many field lines? How many field lines? How many field lines? How many field lines per area? Okay, so the magnetic flux density has a symbol B, and magnetic flux is equal to B times A times cos theta. Now, if we just draw a quick diagram of, let's just say you have an area, surface area A, and you've got the magnetic field coming in this way. So this is the magnetic field. Now, the theta is the normal to that surface and the magnetic field. So the angle is between the normal to the surface and the magnetic field. So if it's perpendicular, so if it's at 90 degrees, then there is maximum, when it's equal to zero. When it's equal to zero. So when theta is equal to zero, because that is when it's at 90 degrees, then it is at a maximum where that is 90 degrees. All right, so let's talk about the AC generator. Hold on. Let's talk about the flux linkage. Now, flux linkage is the number of coils times BA cos theta. So N is the number of coils. Now, another symbol for magnetic flux is phi. So you can also say that is N phi. Okay, so let's just quickly recap. Magnetic flux density is how many field lines per area, how many magnetic field lines per area. And if the magnetic field line is at an angle, then you do cos theta, because cos theta, you want it perpendicular to the surface. And that is phi. So BA cos theta is phi, and that is how many field lines is coming out of that surface. And the flux linkage, you multiply by the number of coils. So N is number of coils. Okay, so when theta is equal to zero, that means when the field lines is perpendicular to the surface, the maximum magnetic flux. All right, so now let's draw a diagram for, let's just say, one AC generator. What does it involve? So an AC generator. So you have a rectangular coil, you have magnets, and it's rotating. So it's rotating. So number one, it has a rectangular coil. Number two, it has N turns of coil. So N turns of coil. And it will rotate and have this magnetic flux density. So 3, it will rotate, and 4, uniform magnetic flux density B. All right. So if let's just say that these are so the arrow here represents the magnetic field. Okay. All right. So let's just say the magnetic field is this way. And let's draw the coil. So let's just say that the coil, let's draw the coil. Let's say the coil is down. Okay, so the coil is down. The coil is this way. The coil is this way. The coil is this way. And the coil is this way. So these arrows represents the magnetic field lines. That is the coil. This line is the coil. Okay, so if we draw a line here, here on the y-axis you have flux linkage. Here you have time. Now, assuming that this is A, that side is A, that side is B. So if let's just say it's rotating clockwise, that is a. Let's not call that A. Let's call that C. Let's call that C. That's C. So now that is C. That's A. That is C. That's A. And that go back to the beginning. So that's A and that's C. Okay. So what is theta in this case? So in this case, the theta, if you remember that it is normal to the surface, and it's that angle between the magnetic field and the normal to that surface. So the normal to the coil is here. So therefore, theta in this case is 0. So in this case, I'm going to write this down. So theta is equal to 0. So theta is equal to 0 for that one. Theta is equal to 90 for this one. Theta is equal to 90. For this one, you can say theta is 180. Theta is 180. In this case, theta is 270. And in this case, theta is 360. Now, if you remember the cos graph, it starts here. So here is when it's 0, 90, 180, 270, and that is 360. All right, so when it is cos of 9, so when it's cos 0, it is maximum. So it has maximum flux linkage there, maximum flux linkage. When theta is equal to 90, it is 0. When that is equal to 180, it is minus. So it is minus here. When that's 270, it's equal to 0. And when it's 360, that is equal to the maximum. So it's just like this cos graph. So it is like the cos graph. So okay, so it is like the cos graph. So here, can you see that? Well, if you remember what Faraday's law is, so EMF is equal to minus d n phi by dt. So can you see there, you have maximum EMF. I mean, it could be maximum or minimum. Now, because you're using Lenz's law, because that's a negative gradient, that will give you minimum, but then the negative of a minimum will give you a maximum. So that's a maximum there. Because that is a maximum gradient, so the gradient here is a maximum, but it's a negative of a maximum, that will give you negative EMF. Here, okay, so So for this one, because the gradient here is 0, the gradient, so therefore the EMF is equal to 0. And here, the gradient is equal to 0 here. So if you were to draw a graph so the dotted line is the EMF. Okay, so the dotted line is the EMF. The flux linkage is the border line.